Statistical estimation of copper, silver, gold, and palladium requirements for the manufacture of mobile phones needed in future. Abstract: today's electronic equipment such as mobile phones, PCs and laptops are tomorrow's e-waste. A mobile phone contains more than 40 elements including base metal copper, Cu, and precious metals silver, Ag, gold, O, and palladium, Pd. Metals represent on average 23% of the weight of a phone, the majority being copper. In 1 ton of mobile phone handsets without battery there are 3.5 kilograms of Ag, 340 grams O, 140 grams Pd and 130 kilograms Cu. For a single unit the metal content is 250 milligrams Ag, 24 milligrams O, 9 milligrams Pd and 9 grams Cu. Analyzing global sales of mobile phones using linear regression equation we can compute the sales of mobile phones in future and estimate the amount of Cu, Ag, O and Pd requirements. Keywords: e-waste, mobile phones, copper, silver, gold, palladium, global sales, linear regression equation. Introduction. E-waste is one of the fastest growing waste streams in the world. E-waste comprises of waste generated from used electronic devices and household appliances which are not fit for their original intended use and are destined for recovery or disposal. Treatment processes of e-waste includes art and craft works, recovery of the elements and uses as construction material. E-waste contains several types of substances and chemicals creating serious human health and environment problems. In India, volume of e-waste is estimated to be 0.8 million tons in 2012. According to the Controller and Auditor General's (CAG) report, 4 lakhs tons of e-waste are generated in the country annually. Clean Kerala Company Limited. Thiruvananthapuram collected 1,372.04 tons e-waste as on 3/1.05.2019. The growth of internet users has grown at a lightning pace and in India it is estimated that about 1.42 million PCs are getting obsolete every year. The total e-waste in India has been estimated to be 1,46,180 tons per year. E-waste has typical application in industry and society before dumping. The major areas of application are utilization of e-waste in metal industry, in construction industry and in charity works. Landfill has serious problems as the disposal at random places causes pollution. 3. Environmental impact of e-waste. E-waste contains harmful elements such as lead, mercury, cadmium and many toxic substances which leach into soil and water polluting the water bodies. If this happens in a large scale the water body will become unsafe for consumption. E-waste recycling is complex and expensive owing to the diversity of metallic and non-metallic components as well as their difficulty in separation. Poisonous gases like dioxins and furans generated as a result of the material extraction process. High volume of acidic effluents generated owing to the hydrometallurgical recycling process lead to the environmental pollutions. 4. E-waste reduction policies. I. Green Protocol. 2. Zero waste. 3. Execution of government orders in offices and institutions. 4. Implementation of EPR and ROS. V. Designers should ensure the product is built for reuse, repair, or upgradability. 6. Enabling legal framework penalties for violation of e-waste rules. The role of e-waste in metal industry. As an example, global sales of mobile phones in 2018 are considered. Its content of Cu, Ag, O and Pd estimated. Also estimated the metal requirements for the manufacture of mobile phones in 2025 using linear regression equation. Total sales of mobile phones in 2018 equals 1,556.2 million units. Estimated base metal content, copper equals 14,006 ton. Precious metals content, silver equals 389.1 ton. Gold equals 37.4 ton. Palladium equals 14 ton. Formulation of regression model for estimation of future sales. Year, X. X equals X. Sales, Y. XY. X. 6 result. Computed global sales of mobile phones in 2025 equals 2,676.72 million units and for that sales of mobile phones. 7. Conclusion. Maximum amount of base metal and precious metals extracted from a given unit of mobile phones are tabulated. Metal requirements for the production of mobile phones needed for the sales in 2025 are also computed using linear regression equation.